Hi, this is the grumpy old IT guy. Welcome to my training video, Building a Data Warehouse. In this short lesson, we will show you how to create a data warehouse to store information about tracking valve operational statistics in a power plant scenario. We will cover the following: creating the data warehouse database with SQL Server, creating all the dimension and fact tables, loading all the dimension and fact tables with window command scripts and BCP bulk loading utilities, creating indexes to increase performance. Write a few queries to create valve operational history reports. Access the data warehouse with Microsoft Excel to create a pivot table for analysis of the historical data. My assistant, Professor Michel Dubois, will take you through the course. Let's get started.
I am delighted to introduce myself to you. My name is Micheline Dubois, and I am joining you from Paris, France. With a robust database management, architecture, and a programming background, I am eager to share my expertise with all of you. Through my virtual career, I have specialized in Microsoft SQL Server, focusing on advanced topics such as performance tuning, storage procedure, and database table partitioning. I am deeply passionate about this area, and I am excited to explore them with you in our upcoming course. As we embark on this journey together, I aim to provide you with the knowledge and skills needed to manage a database effectively. I am committed to fostering a dynamic and engaging learning environment where you can thrive and reach your full potential. I am honored to be a part of the Grumpy Virtual Academy, and I look forward to collaborating with each of you as we explore the complexities of SQL Server together. Thank you for the warm welcome. I am excited to begin this enriching journey with you. And thank you, Professor Grumpy. Thank you, Professor Grumpy. What's our objective in this lesson? We will build a large data warehouse with several dimensions and one fact table. The fact table will store 80 million rows of historical information related to power plant valve failures. Lastly, our objective is to learn the architecture of a data warehouse. We will see that it is composed of a layer of table called staging table. These tables are loaded with the raw data we need for the data warehouse. Lastly, our objective is to learn how to use tools like BCP, which stand for Bulk Copy Utility, and also powerful transactional SQL script to transform the raw staging data to data that can be loaded into dimension and fact table. Are you ready? The create database statement initializes a new database named Plan Operations DW. The containment non-option specifies that this database is not contained, minutely on the SQL Server instance for specific settings and authentication configuration. Next, we need to specify the primary field and field group. Let us start with the primary field group. The primary clause defines the primary storage field for the database, named Plan Operations DW Primary. This field will store critical system level and metadata information. The physical field path is declared, with an initial size of 5 gigabits and a maximum size of 10 gigabits, and it will grow in increments of 5 at a second needed. Next are the other field group. The database is structured into multiple field groups, each tailored to store specific data type. FactFG used for our fact table. This field group will store our main fact table, which will contain measurable data, such as plant valve failure statistic. DateTime FG used for the date dimension, allocated for storing the date and time dimension data, valid for temporal analysis. Manufacture FG and valve manufacture FG, dedicated to dimension table containing manufacture and valve specific information, ensuring logical data segregation. Staging FG, reserved for staging tables that temporarily store data during extract, transform, load processes before loading into the final data warehouse structure. Plan location FG, store data related to plan location, enabling location-based analysis. Lastly, each file group specify a file name for identification within the SQL Server. We supply the physical storage pas on disk and the initial size, 5 GB, maximum size 10 Gb, and grows increment 5. Lastly the transaction log. The log on close defines the transaction log file, critical for maintaining database integrity and supporting recovery processes. The log file is named plan operations dw log and stored in a file called plan operations dw.log. It starts at 10 Gb, can grow to a maximum of 25 Gb, and grows in 5 increments. Easy, correct? What happens if we load the database and run out of space? We can add another file to the file group by using the alter command. The steps are simple. We use the alter database command and include the database name we want to modify. Next, we use the add file command and supply it with the same parameter we used in the create database command to specify the new file's name, file path location, and grow statistic. Nothing could be simpler. Now we are ready to create our dimension and fact table. Next, we need to create our dimension and fact table. We will start with the staging table, which will store the historical operational data that will be loaded with the BCP utility. Here, we see the data declaration language command used to create a staging table called valve operational history. Notice that it is assigned to the staging table schema which we created using the create schema staging table command. Our staging table includes the columns to identify calendar date information, hours of the day, plan location, valve manufacture information, and valve temperature for each hour of the day. Lastly, we include the low and high temperature rating the valve can operate in. Next, we need to create staging table for the dimension table. Our next task is to create the staging table to store the raw data for our dimension table. We will also use the BCP utility to load these from flat text file. There are 5 tables we need to create: the calendar staging table, the manufacture staging table, the manufacture valve staging table, the plan location staging table, the plan staging table. The names imply the data they will store. For example, the plan staging table will store the names of the power plant for which we are collecting information. The plan location table will store the data for the plan location association dimension table. This will allow us to link plan to each location within the plan where the valves are located. Let's continue to our following tasks. We need to make the dimension table now that we have created all the staging table. Why do we need a dimension table if we already have the data in the staging table? Dimension table usually include all the columns in the staging table, but one extra column is added. This is called a surrogate key. A surrogate key is a column that contains the numerical value that will be used. A lookup is then included in the fact table. This way, we can join all the dimension table to the fact table using these numerical keys. Numerical value are faster to join than text or alphanumeric value. Also, when we pull data from staging table into dimension table, we can perform any required conversion, transformation, or cleaning of the data. We have one more table to create, the fact table. Notice all the surrogate keys in the create table command. These correspond to the surrogate keys in each dimension. Right now, besides the surrogate keys, we only have 2 numerical values, which are called measures, when we refer to them in a data warehouse fact table. Later, in our short lecture, we will see a query that ties all the non-surrogate key value in the dimension and the fact table so we can generate a report called a star or multidimensional report. We will use the query in an insert statement to load yet another table, which we will then make available to Microsoft Excel to create a pivot table report. This is a crucial and powerful concept to learn. Now that we have created all of the staging, fact, and dimension table, We will have to load the staging table from some text file stored in a dedicated folder on our data warehouse server. The BCP utilities used to accomplish these tasks. The BCP command shown in our video clip can be used in a Windows command shell, but in our SQL script, we will generate it dynamically as string and then execute it with the exec command. We will take a long time to load the Valve history staging table, but that is how it goes. We can take an espresso and croissant break while it loads. We will also need this method for all the dimension staging table. At the end of our video, we will have a live demo to show how this is accomplished. Here are the remaining BCP commands to load our remaining staging table. As stated earlier, we will use the SQL script to dynamically create and execute these commands with the exec command. The script that contain our dynamic BCP commands will be called from a Windows command shell so that everything can be loaded at one time. We will see what this command script looks like next. Here is the Windows command script you must run to load all the staging table. The power is in the SQL CMD command, which is outlined in red. When the script runs, it prompts you for the drive where the data is and the name of the SQL Server instance. It accepts these parameters in the SQL CMD command and uses them to execute the script called BCP in Valve Ops History. Very powerful and simple. Now that all our staging tables are loaded, we must load the dimension and fact table. We will switch tools. Having used the BCP command line tool, we now use the SQL programming language. The basic format of each query combines the insert select commands. In this clip, we select all the rows from the calendar staging table and insert them into the calendar dimension table. Notice how we construct a surrogate key by converting the calendar dates year, months, and day part to variable character string. We concatenate the three small string and then convert the new string to an integer data type. That is now our unique surrogate key value. Notice also how we sort the retrieved staging table data by year, months, and date. The remaining dimension tables are loaded in the same manner. We will see how this is all accomplished in our demo. We will start the index creation tasks by addressing the staging table. Fortunately, only two tables are large, so we created a primary key index for the calendar staging table and the Valve operational history staging table. As can be seen, we use the create index command to accomplish this task. The first index is assigned to the calendar staging table. It is called pourquoi calendar date and is based on the calendar date column. For the Valve operational history staging table, we need to include all non-measure columns, so we include this column, plan, location, manufacturer, Valve, cal year, cal month, calendar date and sample hour. We will call this index pourquoi Valve Ops History. The pourquoi stand for the primary key, and Ops stand for operational. We make index names as descriptive as possible but keep them as simple as possible. Let us look at the index we need for the dimension and fact table. Our last loading exercise is to load the fact table. We need to replace all the production keys with all the surrogate keys. This means we need to create a query called a star query, which joins all the dimension table to the fact staging table and uses the results as input to the fact table. As you can see, the query in the clip looks rather complex. You need to make sure all the joins are correct otherwise, the query could run for hours if you generate Cartesian join. As can be seen, the query took 2 minutes and 50 seconds to run, and it loaded 76,695,000 rows, almost 80 million rows. This is a good performance. We can improve the performance by adding an index to the dimension table and the fact staging table. One warning, though, adding all the required index will make this a large database, data volume-wise. We will examine this in the following clip.
Hello, this is the grumpy old it guy. Let me review what we will cover in our first demo. The transact SQL scripts for the following tasks will be covered. Set up file system folder, create database, create tables, load tables, create some views for Microsoft Excel. Okay, let's get started.
Okay, here's our first demo. So we're going to basically review the scripts. There's 4 main scripts for creating and loading not only the the database, but creating the tables and loading the tables. And maybe we'll look at an example query once we've loaded the data. What we want to look at is also where the data comes from. So let me just drag this little Explorer window here. We'll look at this folder first. And we're going to load the database from flat files. There's 2 ways that we can load the database. You're going to see both, but mainly the staging data, right? A data warehouse has staging tables for raw data, and then fact tables and dimension tables. So basically, the staging tables will be loaded from a whole bunch of flat files that I created with the BCP utility. I had data loaded in various places, so I just wrote some BCP scripts to extract the data so it would be compatible with all the tables in the data warehouse. But they're basically text files, right? So if I go into this little, let me pick the calendar table. Let me open it up here. Let's see, I always can't find that open with. Here it is, open with Notepad. And let me just drag it over. And here you just see the calendar information. We have a calendar year and the month and the dates, right? So these are all in a text file. So basically the BCP, the bulk copy utility that comes with SQL Server, will load this raw data from this file path directory. Okay, so that's enough. Well, let me mention that what you need to do is to set up a compatible folder structure like I have, but there will be instructions in the course on how to do that. So what we want to do is create this plant operations data warehouse. I'm going to use the mouse to point all over the place. So the first thing we have to do is to go to the create plant data warehouse script that will be made available to you, and just execute it. So I'm not going to do it now because we already have the data warehouse right here. But typically what you would do is, if you already had this database created and you need to, let's say, add some file groups and files, you need to set it in single user mode, right? So you would execute this command, alter database, plant operations data warehouse, set single user with rollback immediate. So what I'm going to do is comment this out, because we're not going to add anything else to the database, and we're certainly not going to drop it for the demo. But I'm assuming you took my first course, or that you know how to create a database. So here's the create database command. We have our files for the primary file group, and we have the name of the primary file group that we give it, the path, the file name, and then the size, max size, and the file growth. Okay, so we repeat this for the file group date time FG, which stands for file group, and that's where we're going to store calendar and date related data. Then we have a file group called fact FG. Well, that's where the fact table data is going to go. And then we have individual file groups for the various dimensions. In this case, we have a manufacturer dimension, a plant location dimension, a staging table dimension that's going to need a lot of data. Then also a second staging file. We assigned 2 files to this file group because there's a whole bunch of data. I had to experiment. I kept loading data and creating indexes, and it would blow up because it didn't have enough space. So I finally came to these settings, which you'll be using. So this could get very big. Then finally, there's a file group for the manufacturer, valve manufacturer data. And last but not least, the log, right? So you should be familiar how to do this. Otherwise, take a peek at my free podcast on creating databases, or I suggest if you're very new to T-SQL programming that you take my course. It's not too expensive, right? There's a little quick marketing on my side. But anyway, executing this script will create the database. So now what do we need to do? Well, we need to go in and create all of the different tables. So we use the Plant Operations Data Warehouse, make sure we're in there. We create a schema called staging tables. And then we have all of the different create table commands. I'm not going to go through all of them, but there's a valve operational history table, line everything up so it looks pretty nice, legible, easy to understand. Another staging table, valve operational history statistics. Well, that's for the fact table. Look at that. And I should actually put a comment in here. Again, this is a very drafty demo. I'm giving you a free preview, but I think that we would be well served, right, if we kind of put a comment as to what this little command does, right? We would like to do this for all the tables. I'll just do it for this one, but comments are very important. They should be very clear so that they describe what's happening in the script, but not be overly complex, right? You want the simplest comments possible. So this will create the fact table. Then here's a whole bunch of staging tables. Okay, manufacturer staging table. Basically, there's different ways to do that. We're going to load all this information, like I said, with the BCP command and the flat files. Here's our calendar table, very simple. You saw the raw data, just the year, month, and date. All right, but there's also calendar dimension. Now, what is the difference between a staging table and a dimension table if they both have the same data? Let me put this bracket in here so it just looks the same. Well, the dimension table, we're adding this key, right, a calendar key. It's going to be a surrogate key. It's easy to join fact tables to dimensions with surrogate keys that are numeric. It's faster to join numbers than character strings. So that's what that key is going to contain. So we're going to perform some simple ETL, extraction, transformation, and loading. Pull the data out of the calendar staging table when it's all loaded up and insert it into this dimension table so that the calendar key will be loaded and incremented automatically. Well, let's take a look. Here's a quick query. So as you can see, well, actually, I kind of lied to you. It is a surrogate key, but in this case, it is not. I repeat, it's not an identity key that automatically gets created. You're going to see that we are going to take the year number, the calendar month number, and the calendar date number. All right, and what we want to do is to convert these. We'll pull out the day component of the calendar date. We're going to convert each of these into a text string, concatenate them together, and then convert them back to a number for the calendar key. So there you see 2015, an 8, and then 17. So that's a unique numerical calendar key. You wouldn't want to use a identity key because then you just have numbers 1, 2, 3, so on and so forth. Whereas this is I think the way to go because it's easy to figure out what the date is. But we're going to look at this again. So we're not going to save this little query. So there's the calendar dimension. There's our plant location staging table. Here's the situation where we have a plant location key, which is a identity key in the plant location dimension. So here it is right here. We'll right click and look at it. So there you see, right, all the locations in the plants, and they have numbers for the key, the surrogate key, just incrementing 1, 2, 3, all the way to 25. So in total, there's 5 locations for each plant that we have to generate data for, test data. So basically, this repeats itself for all the staging tables and dimension tables. Here we have an association table that basically links a manufacturer to a valve. Okay, where is it? I think it's this one. Is this it? Let's expand this name. Yep, this is it. Let's take a quick look at it. So you can see the surrogate key again, but you can see the manufacturer, which valve that they supply the power plant with. And just to keep it simple, there's 5 manufacturers, and each supplies the same plant. Okay, the same valve, I should say. And there's a few more staging table, the valve dimension, which we include the minimum and maximum temperature ratings. And that's pretty much for creating the tables. You just execute this script and it'll automatically create all the tables that you need. All right, here comes the good part. Let's start looking at the complicated BCP commands. Now, BCP stands for bulk copy. All right, and there's 2 ways to execute it. You can basically execute it from the command line. And what this script here does for us is it automatically creates the BCP command. Okay, let me make a little more room here. And basically what happens is there's just a bunch of variables that we need to set up. The variable to store the BCP command, right? BCP command nvarchar max. Then the schema name. This is pretty big, 4,000 bytes. I actually probably could get away with 40 bytes. The database name, the table name, and the drive. So then we initialize it for the particular table we want to load. So the schema here in this case is staging tables. The database is, of course, the plant operations data warehouse. And the table is the plant location stage table, and the drive is D. So we're going to set that big BCP command to a bulk insert. Whoops. To a bulk insert. And then we'll attach the database name, the schema name, and the table name. Then the from clause. And we define the drive, the folder path, and then the plant location, the name of the table that we want to, the name of the flat file that we want to use to load the table. So this BCP command has a bunch of parameters that we need to include, which is the first row of the file. Sometimes a file will have some headers, so you would want to skip those and make the first row 2. Then the row terminator here is a new line. The code page we use standard 65001. A table lock when we do this, and then a path for the error file. So now this pretty much is the same for all of the tables that we're going to bulk load. So I will not go through the other ones. I've commented out the execute statement. This would actually execute the command, but here's what the command looks like. So we can just run this script here, and it'll print out the command without executing it. Now you could actually take this command, all right, copy and paste it, and basically go ahead and put it in a Windows command file and execute it from here. That's a second way of doing it. But we're going to let, or you're going to let SQL Server do the work for you, right? All you need to do is to basically uncomment the exec BCP command. Now, what I've neglected to do here is I forgot to put one command up here. I'll copy this declaration, put it right here. So again, this is a draft video. I have to tighten up the code. Okay, we're going to set up a command to truncate the table before we load it. So I'm doing a little copy and pasting on the fly. And I'm going to, of course, comment out that exec command. So now that I've assembled the 3 lines that I want, Okay, what I need to do is right here, before I generate that BCP command, and I want to get a little neat here, I'll put that declaration for the truncate table command right there next to the BCP command. Maybe put a new line to make these stand out. But what this basically would do is it would truncate the table before you load it, right? So we can have a print command too, right? Let me just put a print command right up here for debugging purposes. But we basically want this in each of the sections of this script. Okay, so we would print the truncate table statement. And well, let's do it. Let's just highlight the declarations. And there you go. There's the truncate table plant operations database, staging table schema, and the plant location stage. Okay, so we did not execute that. We just printed out the command. All right, so basically you just go ahead and do the same thing in all of these, and I'm going to fix up the script so that they all have the truncate command implemented in the script. So that's how the bulk loading goes of the text file. Let's see what's next. All right, there's a couple of ways we can load the plant dimensions. Once we've loaded all of our staging tables, right, we can truncate the dimension table for the calendar first. We can then insert, okay, into that calendar dimension all of the data from the staging table for the calendar. I'll just execute the query without the insert statement. So there you see all that nice data that we looked at in the raw text file. This would go into our calendar dimension table. We could truncate it. And this one also has that, as I explained, that nice little surrogate key. Look at that, a gigantic statement here that will convert, as I said, the year, the month, and the day part of the calendar date into a variable character string. We're going to concatenate those, and then we are going to convert them back to an integer. And then we do pretty much the same operations for all the other dimension tables. All right, same thing, just different table names and code. See if there's anything interesting here. The statistics that we're going to generate will be assigned one of three status codes or status descriptions. The valve is normally operating, or it's the valve failed, a valve failure, or it's offline. So now, as I said, this is a draft, and as I experiment, I do some checks, right? I tried to create an index on the staging table, and what happened was that I got a duplicate key error. But it's nice. It basically tells you which row, all the columns that had the duplicate keys, so I can go and research it. Okay, what I basically wanted to do was update about 100,000 rows here and just set them to that offline status. And when I executed this command, all right, I got the error. Okay, so stay tuned. When you get this script, though, everything will be fixed. But roughly, this command that I executed to load the fact table now loaded, let's see, 52,900,000 and, well, let me do that again. Yeah, not 52 million, but 5,294,182 rows in 1 minute and 39 seconds. So that's not bad. So this is a complicated query. What I did is, well, what I want to do is to basically join all the dimensions to the staging table, the valve operational history staging table, and basically replace the production keys with the surrogate keys. So what do I mean by a production key? Well, when we have the year, the month, and the calendar date, for example, the raw data, that's a production key or a production value. Same thing with plant and location and manufacturer, and so on and so forth. So I've commented them out so that if something goes wrong, I can uncomment them and see, exactly what's happening. But I've replaced them with all of the surrogate keys I was talking about. So there you see we have some pretty complicated joins. We're joining that staging table again to the calendar dimension over the calendar date, then to the plant dimension over the plant name. And we just make sure that we just line up all of these keys so that there's no duplicates. So as you can see, that's a pretty big series of joins, a large number of joins. Then I also do an order by. This way the calendar key and all those keys, kind of line up nicely when I want to create an index. Then we can also create a plant valve statistics cube report. And what we're going to do is we're going to replace those surrogate keys again back with the production keys, but we're pulling them from the fact table. So this is a good check to make sure that the number of rows you're extracting is the same number of rows that are in the fact table and the staging table. So once again, we have all of these dimensions we're joining to. Okay, but this time we're going to print out the data. And now we're inserting them on the fly into that table called Plant Valve Statistics Cube Report. So we need to drop it, and then we execute that select into. Okay, it's a lot faster. It's not logged. When you start getting to millions of rows, if you do an insert into, then the query could run for a very long time. So for our testing environments, this is a good way to load the data. There's a little select distinct. We want to make sure we don't have any duplicates, so we execute it. We get no rows, so in this case, it's a good thing. And last but not least, is pretty much the same code. I had it separated. All right, there's that cube report code we just went through. I'm not sure if I want to keep it in this first script or just have a dedicated script here, but it's the same query. We look for duplicates. Okay, there's a prior message that said, hey, we got some duplicates there, and I try to execute this query to look for the duplicates, and it's going to crank in there. And let me see if I fixed it or not. But, well, no, I didn't. That's good. So there you can see now where I have to do some sort of a analysis of why this duplicate exists. Notice I have 2 rows. All right. Everything is the same. The calendar year, the date, the plant, so on and so forth. But for the same hour, I have 2 statuses. Okay, I have a temperature of 134 and 164. So this is a duplicate that was inserted. There's a create index on the report. That's what generated the failure. I could actually run this index and just basically comment out the unique. This way I would have an index available when I use this table. For Microsoft Excel, we're going to, in our second demo, create a pivot table from the fact table or this report table. But typically when you create an index and load it, you want to also update the statistics, okay? And last but not least, we create some views. I'm sure you know what those are. And let me do something here. Let me just put in a top 100 to test out this view code. And so you see we've replaced the surrogate key in the valve status column with the actual status description, right? Valve failure or normal operation. All right, so let me just take that back out again. And notice also that I have commented out an order by clause. So when you're developing a view, in my opinion, it's first nice to develop the query, have an order by clause so everything lines up nicely. And then there's just a whole bunch of other views that I created, one for plant 1, one for plant 2, so on and so forth. Now, I might actually might want to modify this and say, well, where plant 1 or where the valve is equal to plant 2, for example, just to make this a little a view that returns less rows, right? Because there's a whole millions of rows, as you saw. And calendar year is equal to, I think we saw a 217 there, 2017 as the year. Let me see how many rows this returns. And while it's cranking away there, I use a with no lock, which means that users that use this view, all right, are basically doing what's called a dirty read. That means someone can go in there and update the underlying data, so you might get erroneous data or stale data with this view. But for our purposes, it's a good idea to put a with no lock as we're doing testing and loading test data. So notice we returned 1,130,582 rows. So it's still a pretty big view. We could further, maybe hone this down to a location and maybe even a manufacturer. But I think you get the idea. So the rest of the code here is to just create a whole bunch of views. Let's see if I think I created them all. Yes, there they are. So that when I attach Microsoft Excel to this database, I can pull data out of these views. All right, so we covered it all. I hope you enjoyed the demo. And I think by now you just know how to create this database in the tables and load them up and create some indexes. Okay, let's get back to our lecture.
In the next few clips I will show you how to use Microsoft Excel to connect to our data warehouse and use a query to retrieve data into a new spreadsheet. We will use the spreadsheet to create a pivot table. In our case, Excel will try to load as much data it can, but will eventually return an error as we tried to pull in a million of rows. That is okay. I just want to illustrate the concept and mechanism required to create that powerful analytical tool. In real life you will supply a query to Excel that filters the amount of data that is loaded so it will not generate an error. The first step we need to take is to create a connection to SQL Server. Navigate to the menu bar and click on Data. A new menu bar appears. Click on Get Data Selection and select from Database. In the database list, select from SQL Server. A panel will appear where you will fill in the necessary connectivity information. We look at this in the next slide. Here is the connectivity information panel. Supply the server instance name and the database you want to connect to, and finally, supply a query that is to be used to extract the data. Click on the OK button to begin pulling in the data from the query you supplied. For our simple demonstration, we did not have to supply security credential. We will have another demo that show you how to enter advanced information. Let's see what the data loading step looks like. Once you click on load, sit back. Maybe make an espresso because the loading process could take a long time, depending how much data is loaded. Let us consider that the query we define in the connection step should have a where clause to define filters that will return a reasonable number of rows without causing an error. Then, let's see what the data looks like once it is all loaded. The data is loaded. It took only 2 days. Do not mind me. I am only making a joke. This data is nicely formatted and will be the source data for the pivot table. Do not forget, if the dataset being loaded is very large, Excel will try to load as many rows as it can, but it will generate an error message when it cannot load any more rows. Once again, think out the query you need in the connectivity step so it satisfies the business requirement and loads enough data for analysis. Let us create our pivot table. We are ready to create our pivot table. Highlight the data range you wish to use for your pivot table. Navigate to the menu bar and click the following sequence of selections: Insert Table, Pivotable, and select whether you want the pivotable to appear in the same spreadsheet table or a new one. Select a new tab, and once the pivotable is created, we can begin our analysis. Let's see how in the next clip. All of our data has been successfully loaded. We are ready to begin analysis by slicing and dicing the data. We do this by moving the columns so that they appear in the row or columns of the result area. Let us see how this is accomplished.
Okay, it's the grumpy old IT guy again. Let's see if we can create a pivot table that accesses some of that nice data that we loaded in our first demo. So the first thing we need to do is well, get the data. So we click on, we go to the data pane here, or the data menu selection, the data bar, menu bar, click on get data from SQL Server database. Okay, it's going to go out. It's going to ask me for a server instance. Paste that server instance in there. We need to also use a database. Is the query that we're going to use, by the way. I'll just put it in here. Let me just scroll down here to the from clause. There's our data warehouse. Okay, we need to supply this database. It's optional. The advanced options are, well, we're going to supply a query. Okay, you just saw that query. So let me go here and just copy and paste this whole query here. Okay, and we're going to paste it here, and we are going to click on OK. So it's going to, we encounter an error trying to connect. Oh, doesn't like the syntax near go. Okay, I always keep forgetting. So I'm glad that we have that error. Okay, when you paste the query in there, you just don't need that go. Okay, just click on OK, get rid of the go. It should be all right. And so it's going to, let's see, pull that data in. There it is. Okay, so we pulled the data in, and we need to click on load. So it's going to take a bit of time. There's our connection. It's getting that data. We could go back and do some editing with the connection, refine the query. So there you see a little indication of how many rows it's loading. We're up to over 200,000 rows, and that's about it, I think. All right, so there's the data. Get a little message here. I got it, whatever. Get rid of this here. So it gives you the nice raw data, but in a nice little report. Okay. So what do we want to do? Well, now we want to insert a pivot table. So we click on the insert selection in the menu bar, and let's see, we'll just insert a pivot table from the table in range. Actually, you know what? Let me highlight all this so it has the range already picked up. Pivot table from table in range. Okay, so it picked it all up, so that's good. We'll put it in a new worksheet. Click on OK. So there's our new worksheet, and there's our pivot table. So we're ready to go. So what do we need to do? Well, we will do some slicing and dicing. Let's pick the calendar year. We'll put it down here in the rows. We'll pick, let's see, the calendar month also. It's a little tight to get all this information back here. We also want the calendar date. Put that in here. Now the sample hour I'm going to stick in the columns. We also want the plant all the way down here after the date. And we also want the location. Okay. And what do we want to do? Well, we want to create some filters, all right? So let's see what we're going to do. let's drag the calendar year as a filter here too. And also the calendar month as a filter. I have to do this right because otherwise it'll come up, it won't look too good if you pick the wrong thing. Well, let's pick the calendar date also. We can, hold down on the, well, let's leave the calendar date up here. Let's see, we'll do the location as a filter, and also the manufacturer. That should do it as a filter, I think. Okay. So now what do we want to do? Well, we want to take the temperature and put it underneath the sample hour. Okay, so that should work. Did it work? So let's start slicing and dicing and see what happens here. We'll pick 2017 as the calendar year. Let's pick the calendar month. We'll pick, let's say December. How's that? We'll pick December. Come on, you can do it. Click on OK for December. The location, the generator room. And finally for the manufacturer, well, there's only one. We had it in the where clause. So there's the information, but we're still not seeing anything. So let's drag this temperature down here in the values. And let's see what we get. We have some sort of a cube here. But it seems like it's just listing weird hours, right? What do we need to do this? We'll click on this again and see if we can refine this. We have the sample hours, the temperature as the columns. We have the sample temperature. Okay, so why is this giving me something weird here? Let's pick all the months. Let's go and pick up all the months. Just click on all for the months. So it should basically list out all of the months, and that seems to be working pretty good. But what I'm going to do is I'm going to take the temperature out of here, see what this does. So that did something. It basically summed up all the temperatures and the hours on top, but I don't want that. I don't want to sum all the values. Let's see what we can do. Value field setting. Okay, so we just want the average. Let's put the average there and let's see what that does, because summing up temperatures is pretty much meaningless, right? But there you go. So we have for January, all right, for all calendar years and months, we have the average temperatures for each of the hours. So we just did some nice slicing and dicing. And you could also create a similar pivot table, but as a chart. So you can see the power of using Excel to basically analyze the data. All right, so that's pretty much it on how you set up a simple pivot table. So let's get back with Professor Michel and wrap up the course.
Here is our reward for all our hard work. We created and loaded a data warehouse with historical data for valve components in a series of electrical power plants. We added an index to speed up query performance and create a query to populate a Microsoft Excel pivotable. And that was only part 1. In part 2, we used Microsoft Excel to create a connection to our data warehouse and a pivotable. In this clip, you see the resulting pivotable ready for analysis. We can slice and dice the data by dragging and dropping column names to either the row or column box. We can also create filters to drill into the data to lower levels of the data hierarchy and drill back up as needed. Let's wrap up this tutorial.
Good job, Assistant Professor Dubois. I hope you enjoyed our data warehouse tutorial and that it inspired you to learn more about SQL programming with SQL Server and how to design and build databases. What's next? Please email us at info@grumpyoldguy.com with any comments, suggestions, or ideas. Let us know what you do not like or like and why. Constructive criticism is always welcome. Lastly, for a bit of fun, check out my Facebook page, Artificial Intelligence Art, to see examples of images created with ChatGPT, DALL-E and avatars created with a product called Avatar Builder. See you in my course.